Thank you, Simone. We're going to talk about data because data is super important. First question, of course, is why? Well, I come from a math and computer science background, so I like numbers better than feelings. And when I talk to people about, what they use for data, they go like, oh, I like this better. And I'm like, yeah, but how fast is it? So when I offered to measure it, I just did. And it seems like a very important trade-off down the line, right? Because if you've ever done that, right, changing the underlying structure of your data storage is something that has a huge impact on the rest of your application and development. A few words about how I approach the problem, because math, again, I took 1 gigabyte of data, and I would write the data to disk, and I would read the data to disk and try to manipulate it, and I would measure how fast it went or how much memory we use. A couple of things to note. Generation is random every single time because some of the frameworks that we use cache some results, so you might have some speed up by caching, as was mentioned in the previous talk. And so every time I run the test, the data is fresh and new and cannot be cached. A few words about the baseline. So for reasons that will appear evident after a while, it's the last Mac Mini Intel version that you can buy. It has plenty of RAM and SSD. As I said, it regenerates the data set before each test. And I wanted to try a new framework. It's about a year old. It's called Benchmark. That is promoted on Apple's website. That allows you to measure things with a very high granularity in terms of bytes that you use and milliseconds up to microseconds of runtime on the CPU, wall clock, and that kind of stuff. And so it was an excellent way to try that framework, right? Let's start with the old school way of doing it. Before all the cool and fancy frameworks, we used to just write text to the disk and do our manual SQLite stuff. I wanted to see how well it held up. For reference, so if you just read a JSON, I picked JSON rather than Plist because JSON is a little bit more modern. But once you read the whole data set, so the 1-point-something gigabytes of data in RAM, it takes about the same amount of RAM and the same amount of time to calculate the average for that particular student, that particular class, right? Which makes sense. And as we're going to go through a lot of numbers, keep in mind that once the whole data set is loaded in memory, it takes about 36 milliseconds to calculate the average for that student in that class. And serializing the whole thing to disk, or reading it whole from the disk, takes about 10 seconds. First question, if you want to use JSON, or if you want to choose between JSON and SQLite, right? So if you've done a little bit of computer science, right, you know why databases were invented. That's exactly for that. So we don't have to read the whole text file to find one little piece of data. And it makes sense, right? So it's 800 times faster to use the database for reading. But because of the way the database is structured, inserting data in the database is slightly slower than just writing the whole structure to disk. So you will have a little bit of performance hit when you try to use SQLite manually, but you will have a huge speed bump when you try to read data off the disk. Side notes on that. Please batch your write operations. If you do not, see that's the big pink slice. If you batch by 100 or by 1,000, it's the two smaller slices on the left, right? It's about 10 times slower if you go one by one than if you batch them by 100 or by 1,000. But you don't have to make super complicated stuff, just batch the commands. Next up, I wanted to check if a modern framework that encapsulates and that prevents you from writing your own SQLite wrappers and your own SQL code would make any difference. I picked, not randomly, I picked Blackbird because it's fairly modern, and the approach was interesting, right? It is optimized for writing less code rather than having more speed, which was a nice and bold thing to claim, so I wanted to check it out. And it actually bears fruit, because it's 3 times fewer code than manual SQLite. And as you will see later, right, it allows me to write that piece of code super easily and to debug it, most importantly, super easily. Here are the numbers, right? So in terms of memory, because of the scaffolding and the way Swift works, you have to encapsulate and to wrap every single property and to make sure that type safety is managed correctly. You have schema versioning, like if you upgrade your data manipulation methods. So it's about 3 times, it uses about 3 times as much memory. Remember, we're talking about a few megabytes, a few milliseconds, so it's quite okay. And in terms of speed, we have the same story, right? It's about 3 times slower to use a framework like this rather than just writing your own SQLite code. But it is full async await compatible. It manages migration between your schemas and that kind of stuff. So in my opinion, it's totally worth it. You just have to make sure that you understand the trade-offs of using such a library. And then we have the official way of doing things. So CoreData, which is, by the way, turning 20 next year. And its successor, SwiftData. A few words about that. Can you raise your hands if you ever try to use SwiftData? Okay, about half. So it makes sense to try that out because under the hood it's SQLite, right? But it's also CoreData. If you have ever hit a bug using SwiftData, you will see that you, more often than not, end up in a CoreData function. So it's a wrapper, mostly a wrapper around CoreData. Here are the numbers. SwiftData is about 10 times slower than CoreData. And CoreData is actually faster than manual SQLite by a good portion. It's about twice as fast as writing your manual SQLite code to use CoreData. Okay, at this point you're like, oh, okay, you're just bashing SwiftData. I'm not. SwiftData has an objective in mind that is very different from what I was trying to do. I was trying to serialize a huge bunch of data and read a huge bunch of data, and it is meant to deal with small UI elements. So it is not the same purpose at all, which may explain why these results were so drastic, right? At this point in the presentation, you're like, Zino, you haven't told us what to choose. And yes, and I won't. I will just give you various points to help you choose. If you go SQLite and CoreData, you can know that they are mature and they work, basically, but they have the old syntax. It's C and it's derived from Objective-C. So if you're not familiar or if you're not at ease with these old idiosyncrasies, and we saw a couple of things like that in the intro, right? Don't use it. Also, it is super hard to debug because it is a huge piece of machinery and you have no source code. So again, right, it's about being at ease with that. If you want to use something like Blackbird or other SQLite libraries, they're great for rapid development. The same thing that took me 2 days because of a stupid bug, because CoreData requires an application environment that talks to core services. Took me 2 days to debug that. I wanted to have a CLI tool. The same thing took me like 2 hours in Blackbird. So for rapid development, that's probably one of your best bets. And SwiftData, despite the numbers, I don't hate it. I don't think it's bad. It's just you have to be aware that it's a work in progress. And the differences between macOS 14 and 15 are so huge that there is no way today to tell you if it's going to be the right choice down the line for now. Right? Test it, see if it works for you, and use it if you want. A couple words about benchmark. Whoops. A couple words about benchmark. If you like data, like I do, try it out. It's super interesting. It gives you very fine, granular data on your runtimes and on the memory that you use, up to the megabyte for some things, and up to the microseconds for some other things. So it's nice, but it has a lot of idiosyncrasies. Like it has warm cycles. It can generate some leaks. So be careful with it. It's not ready for prime time yet, but it works super well for people who like numbers like I do. A couple bonus rounds, and then I'll leave you with that. So obviously, Intel versus M1, right? M1 is twice as fast. Kind of expected. A more interesting bonus round is that SQLite is actually faster on Intel than it is on M1 for reading, but slower when writing. Why? I have some inkling as to why. I'm guessing for the right sections, probably SSD speeds that make the difference. And for the reading part is because 20 years of optimizations for, i386. So there's probably a lot going on in there, but it is very consistent. SQLite is super fast on Intel for some reason. And I know that you guys want to talk to me about SwiftData. Come and find me afterwards, I can tell you about it. It is not that I don't like it, it's just that I don't know what to say about it, because the results were super inconsistent during the tests, right? Sometimes, like, it would write the thing to disk, and then the memory would go up from 3 gigabytes to 7 gigabytes after the writing was done. I have no idea why. And so that was my talk about data, and I'm not even too long.
Thank you. Thank you, Zino.
Sorry, it was a lot of numbers.
You are surrounded.
I am surrounded.
Yes.
I surrender.
So how did you, so I'm a little bit curious about the benchmark framework. I know that you were sort of saying it's really good for working with a CLI. Were you able to use it, and you said that there was a serious problem because you weren't able to spin up CoreData without access to core services.
Yeah.
How were you able to eventually get benchmark to work with that?
So I cheated by trying to build a SwiftUI application, because when you write a Swift package that includes SwiftUI, it somehow magically spins out an application rather than a CLI tool. So there are some things going on under the hood that you can cheat with, but if you try to go like pure CLI, you will not get, like SwiftData is actually kind of the same because it's based on CoreData. It will just tell you you can't do that outside of a core services context. Yeah. But it will tell you that after it crashed a couple times.
Yeah.
So, but yeah, if you're in doubt when when testing that kind of thing, try including some SwiftUI code, because then macOS or iOS interprets it as an application rather than a tool.
Okay. Cool. I just want to point out, Zino's wearing a shirt that said, ne me posez pas de questions si vous n'êtes pas prêt d'entendre à la réponse, which basically means, please don't ask me a question if you're not ready to listen to the answer.
Sorry.
And this is a good transition with the next question from the audience. How about Realm?
Okay. All right. So how about insert any multi-platform technology here? The thing is, as you can see with SwiftData and CoreData and SQLite, the more layers you add, the more trade-offs you get. So I'm sure Realm is super convenient where you're trying to do some multi-platform stuff, or when you're trying, because you know that kind of stuff. I'm sure it is. I haven't had to write a cross-platform application for a long time, so super happy about it. So it kind of is unfair to compare performance and memory from something that's meant to be cross-platform versus something that's meant to be native, because you lose all the optimizations. That's why I didn't include it. I'm just saying, test things before you choose, because it has a huge impact on your development cycle. Anyone who's ever had to retool the whole low level of your application, you know what I mean. Test things, make the best choice you can, and have an escape hatch somewhere.
Yeah, I think speaking of Realm, they recently deprecated their major sync SDK, so good luck with that.
Yeah.
Another question I had was, there was a slide in there where you said that SwiftData is more designed to use with sort of smaller data sets where it's mostly just one screen being displayed at a time.
Not necessarily data sets, but smaller extracts.
Okay.
Smaller manipulations with the database.
So what you would say is maybe more like maybe sections of the data set?
Yeah.
Okay.
So my guess is that because, and that particular test, because it's serializing 1 full gigabyte, 1.2 actually, but it doesn't matter. It kind of goes, like if you imagine something like a social feed or whatever, where you have like small views that encapsulate a little piece of data, my guess from the way it works and kind of crashes I got, is that it's optimized for that. like small queries that give you 1 or 2 or 10 objects, rather than I want to grab the whole thing and do some heavy calculation. And it was not meant for that kind of test, right? Like if you are trying to do what I did, like grab 7,000 students and try to calculate the average grade for one of the students, SwiftData is not your friend, because it has to load the whole data set at some point. So yeah.
Fun.
Have you tried to benchmark it on a real physical device, and
Yes.
did you find a huge difference?
Yes, it is all on a physical device. It's macOS rather than iOS. Running the same code on iOS yields the same kind of results. I just got my new iPhone, so I haven't tried on it, and my old iPhone is an SE generation 1. So again, I thought that the benchmark would not be fair, but in the limited tests I did, it is fairly accurate. Like you see the same kind of delta. Like if this thing is 3 times as fast than this one, it's going to be 3 times as fast on all platforms. Yeah.
Okay, thank you, Zino.
Thanks, Zino.
Thanks a lot.